Hello everyone. In this question, it is asked that we are to prove that cos pi upon 32 is equal to half times a nested square root of square root 2 plus square root 2 plus square root 2 plus square root 2. Okay, so there are 4 square root 2, which is a nested square root. Okay, so first of all, let us start with the standard formula of we know of cos of 2x. Okay, this formula is 2 cos square x minus 1. Okay, so first see pi by 32, it is not a standard angle, right? We know the value of pi by 4. This is pi by 4 divided by 8, right? So pi by 4 is 45 degree. Then if we divide it further by 2, pi upon 8 will be 22.5 degree. Then if we divide it again by 2, we get pi upon 16, which is 11.25 degree, right? Then if we divide it again by 2, we get pi upon 32, which is 5.625 degree, I believe. Okay, so we only know this value. Cos of pi by 4 is 1 upon root 2, right? We don't know these values. So let's start with this equation here. From here, if we try to find out what is the value of cos square x, okay, so this will be cos 2 cos square x will be equal to cos twice x plus 1 after changing the sides. From here, cos square x will be half times cos twice x plus 1. Okay, so if we take the square root on both sides now of this equation, we get 1 upon root 2 times square root of cos twice x plus 1. Okay, so this equation we will use this equation, and I have taken positive square root because see the angles here, all of these angles, these are all acute angles, right? All acute angles which lie in the first quadrant. So in the first quadrant, value of cos x is positive, right? So we can take the positive square root here. From this line to this line, we can take the positive square root. These are acute angles. Okay, so now let us start first with, let's say, pi by 8, right? We know pi by 4. Let us try to find the value of pi by 8 first. Okay, now cos of pi by 8, okay, we will use it in this formula, this above formula. Pi by 8 is 1 upon root 2 times, okay, cos twice x will be 2 times of pi by 8 will be cos pi by 4. Okay, so this becomes cos pi by 4 plus 1. Okay, and this now becomes 1 upon root 2 times cos pi by 4 is 1 upon root 2 again plus 1. Okay, so this implies value of cos pi upon 8 is equal to 1 upon root 2 times, if we take the LCM inside the square root, we get 1 plus root 2 upon square root 2. Okay, so let us now try to multiply both the numerator and denominator inside the square root with root 2. Okay, that is, we are trying to rationalize this denominator inside the square root. Okay, so let's see what happens. 1 plus root 2 multiplied by root 2, and the denominator we have root 2 times root 2. So this implies In the numerator now we have 1 times root 2 is root 2, right? Plus root 2 times root 2 is 2. And the denominator root 2 times root 2 is 2. Okay. So now this can be written as 1 upon root 2, and let us separate the numerator and denominator from a single square root. Okay, I'll write it separately instead. So the numerator becomes root 2 plus 2, and the denominator is just a root 2. Okay, I separated the numerator and denominator. Okay, I've just used this formula that square root of p upon q is square root p upon square root q. Okay, I've just used it here. Okay, so if we multiply the denominators, we get half times numerator is 1 plus 1 times this square root, right? So if I write this 2 first, it becomes 2 plus square root of 2. Okay, so the value of cos pi by 8, this expression has taken some sort of a resemblance with what we are required to show here. See, pi upon 32, we are having a nested square root 4 times. We have at least got some sort of structure. Okay, so this is cos pi upon 8. Now we will find the value of cos pi upon 16. Okay, so now cos pi upon 16, this will be 1 upon root 2 times this will be pi upon 8, right? The formula was cos x equal to 1 by root 2 times square root of cos twice x plus 1. Okay, so 2 times pi upon 16 is pi upon 8. Okay, plus 1. So this now becomes 1 upon root 2 times, what is the value of cos pi by 8? We have just found it here. It is half times square root of 2 plus root 2, and this entire thing is to be added with 1. Okay, so this is the expression of cos pi by 16. Okay, so let us now again continue to simplify it further. Cos pi upon 16 be 1 upon root 2 times, if I take the LCM again inside this square root, okay, in the numerator we have square root of 2 plus square root of 2, and this 2 when multiplied with 1 we get plus 2 in the numerator, right? And this entire thing is divided by 2. Okay, so again, like before, if I try to use this formula, this root square root of p upon q equal to square root p by square root q, okay, trying to isolate the numerator and denominator inside the square root. If I try to isolate it, the numerator becomes square root of, if I write this 2 plus first, 2 plus, we have this bracketed term of 2 plus square root of 2. This entire thing is divided by square root of 2. This 2 is inside this bigger, larger square root, right? So we have this here. So now if we find the value of pi upon 16, we see in the denominator this root 2 times root 2, this becomes half, right? So root 2 times root 2 becomes 2, and this fraction becomes half, right? And we are left with, in the numerator, this square root 2 plus square root 2 plus square root 2. So this is becoming a lot like what we are required to show here, right? we have found pi by 8, pi by 16. Now let us finally use the first two derived values and find the value of cos pi by 32, right? Okay. So therefore cos pi upon 32 will be, I will again use this equation, cos x equal to 1 upon root 2 times square root of cos twice x plus 1, right? So this becomes, sorry, 1 upon root 2 times cos of 2 times of this pi by 32 will become cos pi upon 16, right? Plus 1. Okay. So this becomes 1 upon root 2 times, this is in the numerator, right? Cos pi upon 16 is this value. We've just derived it here. It is half times square root of 2 plus square root of 2 plus square root of 2. There are three square roots, three nested square roots, right? And this is to be added with 1. Okay. So this implies cos pi upon 32. This is equal to 1 upon root 2 times. Again, I will take the LCM inside the square root. So the first term is the nested term, nested square root term. Square root 2 plus square root 2 plus square root 2. Okay. And then this 2 is multiplied with 1 to get plus 2. And this entire thing is again divided by 2. Okay. And then again I will use this separation of the numerator and denominator in the third, this square root of p upon q equal to square root p by square root q. I will use this again. So in the numerator we will be left with, I will write this 2 first, 2 plus bracketed term will be square root of 2 plus square root of 2 plus square root of 2. Okay, so this is what is there in the numerator now, and in the denominator we have this root 2, right? So finally if we multiply the denominators now, both the numerator and denominator, the denominator root 2 times root 2 becomes 2, so this becomes half times the square root of 2 plus square root of 2 plus square root of 2 plus square root of 2. 4 square roots, right? And I believe this, yes, there are 4 square roots. Okay, so this is, we have proved it now. Okay, so it is a basically repetitive, we have basically repeatedly used this equation. This equation is repeatedly used here, and I have used the values I have found. Like first I have used the value of pi by 4 to compute pi by 8, cos pi by 8. Then I have used the value of cos pi by 8 to compute the value of cos pi by 16 here. Then finally for cos pi by 32, I've used the value of cos pi by 16 and we have showed it. And the other thing that I have used is I separated the numerator and denominator inside the radical, inside the square root basically. Okay, and I have another key trick I have used here is this rationalization. Here I have multiplied both by root 2, because if I don't do that I won't get this nested structure, nested square root structure, right? It was asked to show this thing in the question, it was asked like that. So this was a extra step that is key step, I would say, very important step here, this rationalization for the value of cos pi by 8. Once you do it one time, you don't need to use it. You get the structure once, then you can repeatedly use this nested value for the remaining values. Okay, so this is it. I've discussed it. It is a slightly lengthy question, repetitive question. Okay, thank you.